Good afternoon. Thanks for joining us today. You are here for the webinar on Blockchain 101, which is blockchain, Bitcoin, and beyond. This is the first in a webinar series that we're holding on emerging technologies, and we'll tell you a little bit about some of the upcoming programs at the end of this one. But first, and most importantly, I'd like to introduce our speaker. We have Christian Lundkvist. Christian is Cryptofinancial Engineer and Decentralization Generalist at Consensys. And let me give you a little bit of background about Christian. Christian began his career as a mathematician. He was doing research in algebraic geometry, and then he took a deep dive into quantitative finance, developing and implementing derivatives pricing models at Bloomberg. Once he started working on Bitcoin, however, he discovered Ethereum and Consensys. Christian now works on a diverse set of projects, including accounting systems, document signing, wallets, and various financial applications. He maintains a general overview of Consensys projects and provides technical expertise when needed. So we're really happy to have Christian with us today, and I am now going to turn it over to Christian.
Thank you, Michelle. So let me dive into the presentation by first sharing my screen. Okay, looks like I have to. Okay, share screen. So I'm going to go into full screen. Can you see that, Michelle?
Yes, looks good. Thank you.
Okay, great. So thanks everyone for coming to this webinar. I'm going to give a brief overview of blockchain technology. So I'm going to start with Bitcoin. So I'm sure pretty much all of you must have heard about Bitcoin by now. And I'm going to explain it from a maybe slightly different perspective than you might have seen in the media. Then I'm going to move on to the blockchain, which is the technology that underlies Bitcoin. I'm going to talk about blockchains that are more general than the Bitcoin blockchain, and then we're going to segue into smart contracts, which is the main kind of use case of the more generalized blockchains. So let's talk about Bitcoin. What is Bitcoin? Well, it's not that, because those are just metal coins. So forget about those for now. Bitcoin is a specific application of blockchain technology. So Bitcoin was the first application that used this technology. And we're going to dive into what this technology actually is. So first of all, what is a blockchain? So if there's anything I want you to get out of this webinar is the following sentence, that a blockchain is a database. So this is fundamentally a type of database technology. So this particular database has very specific properties. So it is decentralized, meaning that you share a lot of redundant copies among participants that are in a network. So this can be a global peer-to-peer network, for instance, as in the case of Bitcoin. But it's also now a lot of research going on for internal networks, so between companies, for instance. So that's one thing. The other thing is you have a strong authentication. So what does this mean? It means that any update to this database requires a digital signature by a private key. So it's very strong cryptographic access control in order to do any type of update to the database. The third point is tamper resistance. So if you have a copy of the database, so like we said, copies are shared, you can get a strong assurance that your copy of the database has not been tampered with, that it is the same one that the rest of the network has. So the above bullet points is what makes the database. So what I want to say, the above bullet points is kind of the things that make this blockchain so interesting. So it makes the database resistant to a minority of participants actively trying to forge and or corrupt data. So even if you have participants that are actively trying to disrupt the network or corrupt the database, these properties makes it so that becomes very, very hard. So, okay, so we've said that the blockchain is a database. So what does that database look like in the case of Bitcoin? So in this case, the database contains accounts. So here is an example of what an account can look like. So it's basically a random looking string. And then each account has balance. So this is, I want to say that this is not quite true. And if you know what unspent transaction outputs and stuff is, then you know that this is not quite true. But for now, this is a good mental model to have. So so you have this database. It contains accounts and balances. And what does it mean to update the database? Well, it means you can reduce the number of Bitcoins in one account and increase it in another account. So this is just what we call sending Bitcoins. So and this is the internal database in a bank works in the same way. If I send someone $100, then my bank balance is lowered by $100, and their bank balance is increased by $100. And in order to have the authority to spend, you have to have the corresponding private key to that account. So we came back to that earlier, where we said each update requires this cryptographic access control. So you have to have the private key for your accounts in order to send from that account. So now we can ask the question again, what is Bitcoin? Well, it's a peer-to-peer network. So anyone can download the Bitcoin software and run this network. It is a blockchain with accounts and balances. I believe this is a little out of date. It's probably closer to 60 gigabytes by now. I have to look that up. It can be used to store and transmit value tokens that are called Bitcoins. And you can think of it as an internal database of account balances, except that it's shared and replicated. So what are use cases for Bitcoin? Well, it's a narrow protocol, but it can be useful for specific applications. So for instance, as currency in I call it a low trust online environment. So for instance, when Overstock started accepting Bitcoins for their merchandise, they were able to open up, I think, something like 100 more countries, because now, even if that country has an unreliable banking system, as long as they get the Bitcoin payment, they know that's final, and then they can ship the goods. So that's one example. Another one is remittances. So we have companies like Abra or Rebit that are working on using Bitcoins to have a cheap way of doing a global transfer. So what that means is that you can buy the Bitcoins with a local currency, send it across the globe for free, basically, and then convert the Bitcoins back to the local currency on the other end. And in certain situations, this can be cheaper than alternatives like Western Union, for instance. So, so let's talk about more general blockchains. And Ethereum is the prime example here. So Ethereum was launched last year, so it has benefited from many years of research into blockchains. And this newer blockchain design it uses the fundamental properties of the blockchain, but it includes some generalization. So what's in the Ethereum blockchain? Well, like in Bitcoin, you have accounts and balances, and the balances here are denominated in Ether, but it's the same type of value token. But the most interesting thing is that it can create, it can hold arbitrary user-created programs. So these are sometimes called smart contracts with a function interface. So these programs have some data, and it can hold value tokens, and the programs can call functions of other programs. So the programs, like I said, they have functions. You can call those functions. It can change the state. It can calculate certain stuff, and then interact with other programs as well. So this is a very general notion, but it makes a lot of things possible. So we talked about Bitcoin. The way you update the Bitcoin database is by sending Bitcoins, basically. And so what does this look like in Ethereum? Well, here there are three ways you can update the database. So you can either send these tokens. So this is exactly like Bitcoin. Or you can upload a program to the blockchain. So you can create a program and then compile it down to it's bytecode, as it's called, and you can submit that to the blockchain, and now it lives on the blockchain. And the third one is you can call a function of one of these programs. So again, very general and abstract principles, but they make a lot of things possible. So I'm going to go through an example of what this can look like, what a smart contract can look like. So let's say we have Alice and Bob. They want to bet on who wins a baseball game. So this is Red Sox versus Yankees. You can facilitate this bet through a smart contract, and we can have a third-party service such as ESPN. They can maintain their own smart contract, which has sports scores and other data that can be read by our original smart contract. So a service like this is sometimes called an oracle. So an oracle posts data to the blockchain. So let's see how this can work. So first, Alice, she creates a smart contract, uploads it to the blockchain, and she includes her bet. So Alice bets that the Yankees will win. So she puts the bet in there, the data that says that she bets on Yankees, and then she also puts the funds there. So Bob comes along. He says, okay, I want to take that bet. I'm going to bet on Red Sox. So he sends some data, which is the data that he bets on the Red Sox, and he sends some funds to the contract. So now the smart contract, it sits there on the blockchain. It has this data about who bet on who, and it has the funds. So, okay, so then it's game day. The game is played. Red Sox wins. So what happens now? ESPN, they have their own smart contract. They will publish this data saying that the Red Sox has won. Okay. Bob now sees that he won. So he says, okay, great. I wanna claim my winnings. So he can now claim the funds. So how does that work? So he calls a function of the contract. The contract then calls a function of the ESPN contract, which I said get winner. So the ESPN contract returns the winner, which is Red Sox, and the contract can then verify that Bob is indeed the winner, and then the contract sends him the winnings. So this is a simple example, but as you can see, we were actually able to create a service that can facilitate this kind of bet without any third-party interference. So this was only between Alice and between Bob, but once the smart contract is created, both Alice and Bob can be sure that this is going to be a fair outcome. So there is no third party that can go bankrupt and take the money or anything like that. And so you can imagine that, here was a simple bet, but, more complex bets are sometimes called financial derivatives. And so those are an example of things that can be done with, maybe can be improved using smart contracts. We are researching this notion of triple entry accounting also, where instead of having one accounting book per firm, you can actually have the transaction going through a smart contract, and then the smart contract can be referenced from both of their accounting systems. So this is kind of a something that accountants are interested in. And you can think of efficient interbank settlements. So there's a lot of interest in making the banking system in general more smooth. Legal contracts that can be self-enforcing. So the bet was a very simple example of such a thing. A property title transfer. So this is in general the ability to tokenize various assets and then move them on a blockchain. And so there's also a more pragmatic reason that if you have some kind of application, and if you have the application logic on the blockchain, there is less need for a server backend. So it can actually potentially save you money on hosting costs, etc. So, but again, only blockchains are not good for heavy computation. So it's just these types of very simple business logic. So in general, we have this idea that if you have a smart contract with a front end that can be created in something like JavaScript, HTML, CSS, this allows for what we call decentralized applications, or dApps. So the application logic lives on a blockchain and has no need for a trusted third party. So just briefly about Consensys. So it's a blockchain production studio. So it's a venture studio model focusing on blockchain technology, mainly Ethereum now. So we build various decentralized applications, but also basic infrastructure for the ecosystem. We try and identify areas where blockchain technology can improve life. And as I said, right now we're working mostly on Ethereum, since this is currently we've identified as the most developer-friendly blockchain. So that's it. Thank you. And I'm happy to take any questions that you might have.
Christian, thanks very much. Okay, we have a few questions, and I also wanted to make sure that I let people know that they can submit their questions by clicking on the Q&A link. I think I forgot to say that at the beginning, but some of the smart people on the call figured that out. So one of the questions was actually, I think, answered, and that was looking for an example of a smart contract, which you provided. Another question that came in is the smart contract code visible to all parties in the blockchain?
Yeah, so that's a good question. The smart contract, so you have the source code, which is the human readable part, and then you have the compiled code, which is kind of like what the computer reads. So the compiled code is indeed visible to all parties, and so that's one of the so privacy is a real concern when it comes to blockchain. So you can't store something secret like a private key on the blockchain because everyone can see it, and so you need to for public blockchains you need to have that in mind and make sure that the logic itself doesn't contain anything that is let's say proprietary or can have impact on privacy. But I don't know if the example of a smart contract in action, maybe that meant a live example, something that's working now.
Well, I think the individual actually emailed back again and is looking for an example of smart contracts that financial services participants, he specified non-gamblers, might use
okay.
To manage client and vendor interactions.
Yes. So so I think for purely financial applications, right now the main focus is on private blockchains. But we have, for instance, a demo of a total return swap. So our CFO James Sloss has demoed this a number of times. But one of the things there that we do is we use the blockchain to actually do real-time collateral rebalancing in a derivatives contract, and so at each tick you can kind of automatically flow funds between your asset account and your collateral account. So that's something we've demoed, but right now it's still very early days for blockchain, and so most of what we have is on the demo stage. There's also been work on smart bonds. So UBS has done some work here, and it basically it uses the blockchain logic, the smart contract logic, to automate payments, etc. Anyway, maybe we can move on to.
Sure. Okay.
So maybe risk of hacking, maybe I can, security?
Yes, go ahead. I'm for some reason I can't see some of the questions that are coming in, but if you can see them, Christian, please go ahead.
Yeah, okay. So Frederick asks, is there any risk of hacking, and what's the security? So one of the kind of selling points of blockchain is just how secure it is. So the blockchain system itself, since it's designed so that it's resistant to attack by its nodes, you kind of have to take over most of the nodes in the network in order for an attack to succeed. But the other security consideration is, since you're using these private keys in order to authenticate to the blockchain, it's very, very important to have a secure way of storing that private key and signing transactions. And so we're working on building solutions like that are secure and easy to use. So can you explain, let's see, can you explain more detail about triple entry accounting? This is Ronald asking. Mm-hmm. So the main idea is double entry accounting. You have two firms. So in one firm you have or in both firms you have a credit and a debit, and the credit and the debit needs to balance. And nowadays the way it works is that each firm has their own books. So they each have their books and the credit and the debit balance in each of them, but there is no link between them. And so what we've done, and we have created a demo of this, is that you can have something like an invoicing flow, where one firm sends an invoice to another firm. This invoice is a smart contract, and when the invoice is signed and paid, it actually can itself be it can be stored on the blockchain, and it can be referenced from each of the accounting systems of the respective firms. So the books of the respective firm would just contain an identifier that points to this shared record in the blockchain. And so in this way you can have an actual link between these two firms. And so this makes it harder to commit fraud, because you have to kind of have the other party involved also. So that's the core of triple entry accounting. So the term was popularized in the 90s by Ian Grigg. Let's move. Carl says, how do you tokenize an asset? Who is backing it? Yeah, so this is a good question. So in general, you can create a token out of thin air, and it might not represent anything, but basically it's kind of in the same way that right now banks, like my bank account, is just some numbers in a database, right? And the bank is backing that and saying, okay, these numbers actually represent the money in my bank account. And so the same thing you could have on a blockchain, where the bank, they create some tokens, and they now say, okay, these tokens actually represents US dollars that we're holding in a vault. Or one project I'm involved in called Transactive Grid, we're actually tokenizing energy. And so now you have an energy meter that is measuring the energy produced from a solar array, and then signing that measurement and creating a corresponding number of tokens. So this is now the backing is the energy meter and the kind of the integrity of the energy meter. And so this is an example. And then, you know, regarding the value of those tokens, that can be either set by the market or some other mechanism.
Christian, another question we got a little bit earlier was on, let's see, is the smart contract code visible to all parties in the blockchain? And then I think there's a follow-up question to that also, but maybe you could start with that one.
Yes. So the code is visible in a in a state that's not so easy to read, but it's definitely possible to read it. And so this is something to keep in mind, that, you know, if you have private information, that you shouldn't put in a smart contract. Is
it possible to make it private?
So
would that be relying on a permissioned blockchain, or?
There is a lot of research around this. So if you have a permissioned blockchain, then or a let's say a consortium blockchain, then you can have the members of the consortium can see the various smart contracts, but so what we've been doing is we've been investigating various ways of kind of hashing information. So you can kind of scramble it if you want, and putting that on a blockchain. And so by using this, you can kind of prove the existence of some information at some point in time, but you can also without revealing it, but you can go back later and verify that the information matches some other type of some other information. So there are ways of creating private data on the blockchain, but it's very hard to compute on that data. So that's sometimes you hear words like homomorphic encryption, etc., and that's that has to do with with private information being computed upon. So, but yeah, the short answer is right now the code is public.
Okay, Christian, the next question is, does the most recent blockchain carry details on the entire history of transactions, or does it only reference the prior block?
It only referenced the prior block. So it's okay. So this has a few. There's a little more nuance to it. So in blockchains like Ethereum, you have a state database, and so you can basically. So it doesn't just contain the transactions, but it contains the state also. But in general, the idea is that you have a reference to the past block, and then you can go back in time to see past events.
Okay, and how does the blockchain make sure that the terms used? Let's see. How does the blockchain make sure the terms used, that everyone agrees on the terms in the smart contract?
Yeah, so it's more of a, so the word contract is a bit of a misnomer. So we should really call them programs. And so when you write a program and run the program, if in this case, it will always do the same thing. But in general, it's a good question, because you have to now make sure that everyone understands what the program will do. And so this is, not everyone is a programmer. So there's been, there's going to be some trust here that the program does what people claim it does. But in principle, you can always go through the code and make sure that it does what you expect. So there's also, there's a lot of interest in actually having, coupling these programs with actual legal contracts, and so then the semantics gets very interesting. But that's still very early days.
Okay. Christian, the next question: are all contracts private so that legal oversight of blockchain agreements and use is limited or non-existent?
Yeah, so I'm not sure what private means. So I guess it means that it is between two individuals, or because private as in private data, that's not true, as we covered. It's all publicly available. But legal oversight, yeah. So the thing is that in a public blockchain, it is a world computer, you can think of it, that has programs, and it will execute those programs when you tell them to execute. And so, the legal implications of that is that you have to have, if you want to use smart contracts in business, you would probably need to have a corresponding legal agreement that says something like, we agree to be bound by the actions of this smart contract, or something like that. And this is also an active research area.
Okay. We were also asked for some more ideas about applications of smart contracts in other industries like health and art and publishing. And the question was also raised: are there other examples on the Consensys website that people can take a look at?
Yeah, so if you go to consensys.net, there is and if you go to, I think there's a website called Spoke Projects, and you can see the various projects that we're working on. So yeah, there's a lot of applications of smart contracts, and that's one of the things we do and try and figure that out. So we had, for instance, one interesting one is the music industry. So the music rights settlement process now is around 100 years old, and it's extremely outdated and frustrating for content creators. So we created a demo called Ujo Music, that an artist can upload a song and they can get paid, and the payment is immediately routed to the relevant participants. So you can have the songwriter gets 50%, the person who played the guitar gets 10%, etc. So that's an interesting smart contract. So I also said energy. The energy sector is very, very interested. Art, we're looking into the concept of art provenance. So basically tracking ownership of artwork. So this is a big pain point in the art space right now that people are looking to blockchains as a way of solving. So that's a little example.
Okay, Christian, how can transactions be audited on the blockchain?
Yes. So is it how or just can they be?
How?
Oh, how? So well, the first thing is that the blockchain is a transaction ledger, so all the transactions are there. So that's a good start, and it's one of the good things is that all the interactions with smart contracts and all the transactions that are sent are always they're recorded, and in a way that cannot be erased, and they're also there is strong attribution. So you always have the private key that created the transaction, or that signed the transaction. And so yeah, there is not one answer to this question. Various different various different application requires different auditing processes, but in general, if all the transactions goes through the blockchain, it's very easy to audit because you can follow everything. So I guess one point is tying those audits to real people, so that there the idea of digital identity comes in, and so that's also one of the projects that I'm working on to try and how do you represent real world entities in contexts like this. So that's a big discussion too.
Okay. Another question is, for financial use cases, private blockchain. It sounds as if private blockchains would be preferred. Assuming that's the case, how do you think the database efficiency will be?
Yeah. So in the private case, you can have a lot of efficiency gains as opposed to the public case. So for instance, in Bitcoin, you need this expensive process of mining in order to secure against malicious nodes. In a private blockchain, you often have nodes that are known to the network and they're legally accountable, and so there is not as much chance that a node will kind of turn evil and start attacking the network. So if you remove the mining component, you can have a lot more efficient the operation here can be a lot more efficient, and there are initiatives to create databases that are custom made for basically processing blockchain data.
The next question, Christian, is how scalable is blockchain technology? Can it eventually replace online banking?
Yeah, so this is also a very good question. When it comes to private blockchains, as I said, it has a lot of efficiency gains, and there I think you can actually you can probably replace a lot of internal bank processes in a scalable way. Public blockchains right now are not particularly scalable. So we see it in Bitcoin, for instance. They're kind of reaching the maximum transaction limit, and Ethereum is currently unscalable, but there is a clear upgrade roadmap for more and more scalable solutions. But scalable public blockchains are probably, I would say, 2, maybe 3 years away. And so the question, can it replace online banking? Well, banks are not just about transmitting value. So, they do lending, and they do, they're kind of like a trust anchor also. So I think, in terms of replacing the value transfer aspect of online banking, I think, yes, within a few years, I think it can probably do that.
Okay. The next question is, how can I store a large amount of data, for example, documents or files?
Great question. So, as I was saying, maybe I didn't cover that. So the way blockchains work is that right now, at least, every node processes all transactions and stores all the data. So it is a fairly expensive process, and in Ethereum, this is reflected in the fact that you have to pay fees in order to do computation and store data. And so if you have a large documents or like images or video files, etc., it's currently not realistic to store those on a blockchain. So what we do is we use an external system. So this is something, there is a system called IPFS, the Interplanetary File System. So this system can, it's what we call content addressed. So you can take a hash or a digest of the file, and you can put that digest on the blockchain. So this is just 256 bits. And what you've done there is basically you have a reference to that file, and it's that reference uniquely maps to that file. And so you have to store that file in a way that you can retrieve it, but as long as you can retrieve it, it has the the network is still in consensus of what that file is.
Okay. If contract details and account numbers are public, can the actual identity of the underlying account holder be kept confidential?
Even if the contract details. Yes. So blockchains are a pseudonymous system, I would say. So if you don't make a link to the identity from the account number, then yes, you can keep the account holder confidential. The thing is, though, after some time, if you can link that account number to an individual, then you can always go back in time and see all their transactions. So there are privacy aspects there for sure.
Okay. A question on the difference between a permissioned and a permissionless blockchain.
Yes, good question. So A permissionless blockchain is something like Bitcoin. So it means that anyone can download the software and start being a node on the network. So there is no, you don't have to ask permission for anyone. Anyone can join, and anyone can send transactions into the network. So sometimes this is called a public blockchain also. A permission blockchain, what it means is that the nodes on the network are all, they need to have permission from some central party or authority. And so an example of this could be let's say you have a consortium of banks, and each of the bank is a node on the network. And the only ones who can join that network are the member banks. So that's an example of a permissioned blockchain.
Okay, the next question, we'll just take a few more here, Christian. But we have a lot. We're getting a lot of questions on this. And I'm not sure if this one has been answered, but what is the viability of using blockchain on a large scale? We talked before about scaling up, but I'm not sure if this is like a question.
Yeah. Again, that question can have many interpretations, but you know, in some sense, Bitcoin is a blockchain that is running on a large global scale. You know, it doesn't do that much, and it doesn't have a lot of users, so it has scaling issues. But this is again back to the scaling debate. So all public blockchains now are you know, scalability is a big issue. So in Bitcoin, there's a lot of debate about what's the best way to scale it. In Ethereum, there is a roadmap of upgrade paths, and so I believe that there is a way of creating a blockchain that can scale and you know, have Visa level amounts of transactions or even beyond. But right now, you know, blockchains are I think so Andrew Keys, who works at Consensys, I think he said that, you know, 2016 is kind of the year of the proof of concept. So the things we're building now is more like, okay, these are things you can do, and meanwhile the blockchains are getting scaled, and once they are shown to be scaled, then we can actually start, you know, building production systems. So, but there are also people who argue that the scaling issues might be larger than we expect. So it is unclear. Personally, I think it's possible.
Okay. The next question is, are third-party services secured by the blockchain? Maybe a little bit general to answer, but if you want to take that on, Christian.
Yeah, I'm not quite sure what it refers to.
Maybe we can go on. Should we just go on to the next question?
Yeah.
Okay. And apologies to the individual who asked that question. We're just not quite sure if you want to email back again. Okay, the next question is, it sounds like human readable source code is not visible to all parties. So how can parties validate that the code in a smart contract is not doing something nefarious?
Yes, excellent question. Indeed, if you just see the kind of compiled bytecode, it's very hard to say what the smart contract does. So I think a a design pattern that's going to come up a lot is to store the actual human readable source code along with the smart contract using a system like IPFS that I described earlier. So if you do this, you can grab the human readable source code, you can compile it yourself and verify that it matches what's on the blockchain. And so if you do this, then it's enough to actually read that human readable source code in order to know that this is the correct program. But then again, some people write code in a way that's very hard to understand, and so my take is that there's probably going to be professional services that review source code for smart contracts, and maybe have some kind of insurance that we've checked the code and we ensure that these things are not going to happen, etc. And so you can have a market for those things.
Okay, Christian, why don't we just take one more question? And we've got a couple questions actually related to searches.
Mm-hmm.
So it's, how do you search a blockchain database, and is it efficient to search in blockchain databases as in traditional databases?
Yeah, so that's a very good question. There are there is a project called or a company now called Block Apps that was incubated within Consensys, and they have a system where they take the blockchain and then they put it in a Postgres database, and so you basically then search that database. So but in general, search is something that's not quite explored, and right now blockchains are kind of small still. So Ethereum is something like, I don't know, all the data is like 50 gigabytes or something, and it's not it's not that hard to search. But as it scales, as it grows, that's going to be a bigger problem and a challenge.
Okay, great. Listen, we do have a lot more questions, and I apologize that we're not going to be able to get through them, but what we will do is go through the questions, and if there are some that have not yet been answered, Christian, I may come back to you and ask you for answers to some of these questions, and then we'll try to respond back to the individuals that pose the questions, if that's okay.
Yeah, so there was one here that says, I was asking if the third-party services are themselves smart contracts. And yes, they can be, or they can be, like in our gambling example, we had a third-party ESPN. They would have a smart contract that they can update.
Okay, great, thank you. Okay, well, I want to thank Christian so much for your talk today, and obviously it's generated a huge amount of interest, and we appreciate the time of our attendees also. I wanted to let you know about a couple of programs that we have coming up. We have some additional webinars. We have another one on smart contracts and data standards. It gets a little bit more specifically into smart contracts, and so many of you who have had questions can join that one and get a kind of a different angle on it maybe. And we're going to have speakers Jeff Billingham from Market and Seth Phillips from ItBit. Then we have a follow-up session on the landscape for blockchain technology. And this program is going to talk a little bit about the different types of blockchains and then kind of the infrastructure kind of on top of the blockchain and talk more about different companies that are involved in blockchain technology. That's going to be June 8th. These are, of course, free webinars, and that one, Campbell Pride, our CEO at XBRL US, is going to be giving that one. And then finally, I want to introduce an event that we have scheduled on June 28th, and this is an in-person half-day forum on crowdfunding and data standards. And this one, we've got a really good lineup of speakers from the SEC, from FINRA, from the CFA Institute, from Computershare, and then a number of companies more in the fintech area, Bankroll, Crowdnetics, and Fund America, and then also Market as well. So that's going to be a half-day program. You do need to register to attend, and attendance will be limited. It'll be similar to the fintech forum that we did on blockchain, where Christian spoke back in April, back earlier this month. So we're excited about all the different emerging technology programs we have going on. There's a lot we'd like to share with you, and we hope that you'll attend. And Christian, thanks very much. Christian Lundkvist, Consensys, did a terrific job, and I'm sure we'll be hearing more from Christian in other programs we have going forward. Thanks.
Yeah, thank you so much, Michelle. Thanks for having me.
Thank you. Bye now.
Bye.